Sustainable construction and permaculture offer practical responses to today's environmental challenges by reducing resource consumption, improving resilience, and creating spaces that work in harmony with nature. In this episode of Friday Frames, architect Mayank Mishra discusses working drawings and construction techniques for sustainable homes and community spaces, sharing practical approaches to designing with ecological responsibility at the forefront.
So yes, good afternoon to everybody and a warm welcome to today's webinar or a session on sustainable construction and permaculture. On Saturday, we discussed rating systems, and now we move ahead to come into the construction details and planning of the site and its surrounding ecosystem. Throughout this session, we'll gain valuable insights from experts leading the way in sustainable architecture and land stewardship. Here's a brief overview of what we'll be covering. We'll be decoding working drawings and construction techniques for sustainable homes and community spaces. We will be exploring innovative materials, passive cooling strategies, and water efficient design for energy smart buildings. This will be led by Mayank Mishra. Applying permaculture principles to develop self-sustaining, climate-resilient farms, understanding efficient dry land farming techniques that conserve water while enhancing soil fertility and crop yield will be handled by Mr. Gopal. I thank both of you for being there at this session and supporting our initiative.
I will be showing two projects today. One would be a convention center, another would be a residence. I will be first showing you the concept and the approach to it, and then we'll be talking about what all went into achieving those as the end goal. So I hope you can see my screen.
Yes, it's visible.
Yeah.
Not full screen yet.
So, yeah. So is it full screen now? Getting the full screen?
Not yet.
Wait.
Yes, we got it.
Okay. So this was a convention center designed for a project in Jabalpur. It was a competition project set by Jabalpur Smart City. They had a very tough site which was in the center of old Jabalpur and the new Jabalpur, which would mean that old Jabalpur was pre-British era Jabalpur, which was a completely built up site with the style of construction it had was very closely placed homes and all of those. While on the right hand side, what you see was the British era construction style, where everything was sparse, the buildings were monumental in nature, and they had their own style of construction at that point of time. This site has an interesting approach from various locations from the old city and the new city both. This is basically what it covers. It also had a proposed green road running parallel to the site, which becomes one of the most important points when we were designing the whole complex. These are some of the pictures which was from that green road. So it was still under construction. Most of it was designed. So what happens at the urban infrastructure level is people do end up designing the green roads, but they don't end up looking at the nearby low roads of what is happening to it. So we had a proposal to actually make it much better. So this was the current situation. And instead of going with the business as usual model, we decided to use the ROW to create a separate walkable area, which could be for the pedestrians. And being a convention center, you would have lots of people coming in buses, which could be public transport provided by the center or by the organizer, which can also, the road outside can also act as the places where people can get dropped off and picked up, reducing the stress on the site. Why I'm saying reducing the stress on the site? Because the site was very tight. It was about 2.8 acres, and they were expecting people in the range of 3 to 4,000 coming into this convention center. So the right of way was again redesigned in a way where you can have bus drop-offs, walkable areas, and still use it as a two-way carriageway, which was already planned as it was. It had two existing trees. This was not easy to retain, so we had to let them go. There were some existing schools and other complexes on the campus. This is how the site was. So the rear side is what you see, the green road, which becomes parallel to this road where you see the cursor is right now. So I will quickly jump to the zoning. We had various options for zoning of where to place what. It had a hotel for about 40, 45 rooms with a banquet hall facility, a convention center, and a spillover greens, which was required as a part of hotel or convention area. These are various zoning options, and they had their own pros and cons, which we also shared it in three-dimensional. Right now, I'm just going with the zoning bit. And the best option that we felt was, see, there was an existing school which they were not sure whether they will be able to relocate it to somewhere in the city, or will it continue to remain on this site. So we planned it in such a way that the school and the banquet hall can have a shared green. So at the evening time, the banquet can have a spillover, while in the daytime, the school kids can use the greens for the play as a play area. This was a school till up class 4, so it was only a primary school. So it didn't mean that you would need a large play areas, but areas where they can actually get together, run, and all. The convention and exhibition facility was placed more towards the road to reduce the congestion and allow quick ingress and egress from the site if there is any parking happening inside. There was a central court which was planned in such a way that it becomes like a buffer area for both these spaces. So this is how it was planned: the banquet, the convention, and the... Now, when we were doing this planning, we had an option to actually locate it, I mean, the orient buildings in a way where the convention center could be incorrectly oriented or the banquet could be incorrectly oriented. By the meaning of incorrectly oriented, I would say that whether it would have a north-south orientation, which would mean reduced air conditioning demand, or which part of it we would want to compromise on. So we decided to compromise on the hotel part, reason being that we had a good buffer in front of a hotel as a balcony, which could shade the whole hotel block, and we proposed to have a jali that you will see in coming elevation. So east and west light could actually be blocked by the help of balconies, while convention and exhibition, which is a major energy guzzler, I would say, because you have lots of air conditioning demand and also lighting demand. We planned to orient it in such a way that you can actually reduce the air conditioning demand and also have a daily space in those areas, which is not very common. So mostly what we end up looking at, the convention and the exhibition centers generally don't have daylit spaces. Why? The reason being that in past we didn't have large possibility of large projections being done with because it didn't have a very high contrast ratio. Now with good LED screens, you can actually have projections and you can have lots of things happening even in a well daylit space. So we decided to not go with a convention center, which would not be a daylit, but have an exhibition area which could be a completely daylit space. It had an auditorium on top of it. Now, auditorium was a space which would still need to be dark, so that if there is any function happening, it needs to have that kind of focus towards the stage. And that's why the auditorium was decided not to make it completely daylit, while the exhibition areas, the conference rooms were decided to be planned as a daylit space. The other important aspect was looking at the urban design aspect, that instead of creating a space which would actually hamper the movement, we decided to pull up the whole mass of the building and use this space as a buffer area, which would act like a stilted space. And this is something which city can use without paying for the convention center. This would act as a as a space for exhibitions and uh, places where people who can't afford to take an exhibition hall can actually take these spaces and use them as a space as an area where they can display and have expo in this part. This is the daylight analysis which I was talking about. So you see the hotel block being placed east and west, the major part, while the convention center has a good north and south exposure to it. These are various shadow analysis which were done at various locations to see what is happening inside the courtyard, which shared between both the blocks. Sorry. This is the site plan. I will quickly jump. Left hand side is the convention, and the right hand side is the hospitality or the hotel block connected through a bridge. Uh, so this is where the exhibition hall is, and we decided to have good daylit spaces. So we placed a lot of windows on left and the right hand side. Similarly, it had lots of other facilities. Exhibition area was double height space. Then there were other halls which had possibilities of opening towards again south and allow the south light inside the smaller 200 and 300 seater seminar and the other banquet types of. And on the right hand side is what you see the hotel area. The topmost floor was again the convention main activity, the auditorium block, which would have about 1,000 people sitting inside it. And this we earlier planned to have a flat floor, but later on client decided to go with a raked floor and not a flat. The good thing about having a flat floor, which we felt should have been done, but it was a client's call, was that you can use it for multiple types of activities, which is now very common. And you can also use these kind of seating, which can be actually pushed and it could be mechanized in a way where everything can go back and you can still have a large floor area. These are some of the views which were of the initial stage. Again, I will quickly zoom in. This is the floor, which is completely tilted, which allows people to use this as a free of ticket area and can be used for smaller exhibitions where people don't have to pay for it. The top floor was the auditorium. We allowed a good winter sun to enter the complex and summer sun to get uh, cordoned off by using horizontal fence. And I will also discuss about the roof and other areas in coming slides. This is a section through the block, the hotel block, banquet at the lower floor, restaurant, service floor, and the hotel block on top. Now, these are some of the simulations which we did early in the concept design stage to make sure that whatever we are planning to have a well-lit convention exhibition hall, whether we are able to achieve it or not. So this was some initial study that we did. Again, some more studies to show, okay, we are getting a good amount of lux level. So anything above 300 or 400 is a good lux level because then you can have your independent lights if in case you need to highlight any product or something of that sort. These are some of the views. So important aspects of designs were to have a green road wherever there is no heavy traffic movement, which could end up looking like this. Um, Mainly pedestrian first policy, vehicular parking in the basement, the rooftop to be used as a productive landscape and for solar photovoltaic. The glazing to be faced to north and south, maximum plus or minus 15 degree, which is what we tried, and also have enough shading device to it so that you don't get blockage, so that you don't get harsh sun coming inside the building. Again, enough depth to allow winter sun to enter. Well insulated facade. This was an important aspect of design, which mostly people don't look at. Now, convention centers like spaces have a huge energy demand when it comes to air conditioning. It increases as people enter inside the building, and this is a peak that you get suddenly. It would mean that at any one day, you would suddenly have a huge amount of air conditioning requirement because an event would be happening there. Now, it was important to insulate the facade of the building to make sure that we don't increase this demand from the external heat. That would mean that if there is any event happening in the month of May or a June, when there is a much of hot and humid air outside, or if it's only hot outside, we should not increase the heat load inside the building because of external conditions. And all that you need to cater for is the people who are coming inside the building and to cool that space. And that's why we propose to have a well insulated facade. This was one of the pictures which we showed to the client early on to have them and make them feel confident that this is doable because we have done something like this in our buildings which are about 15, 20 years ago, which gave the confidence to the client. Using low embodied energy material, I will quickly jump. I think I'm, and that would mean using local stones wherever possible, allowing rainwater to percolate through means of bioswales, and use of lots of stones and other materials, and have a rainwater either stored or recharged. These were some initial diagrams which we shared with the client. This was during the concept stage for the energy of how it could become a smart grid-based building, and water diagrams which would show of how each drop of water is actually traced to STP, then goes to the treatment and then used for the chiller or goes for the irrigation or is being reused for the flushing purpose. When it comes to air conditioning, we decided to have a district cooling system, which would mean that in places where there is exhibition happening or an event happening, at that point of time, all the 45 rooms which are occupied in the hotel would not be occupied because people staying in that hotel will be using this space here. So we decided to have a district cooling, which would mean sharing of air conditioning between both the buildings through a chiller. So in that case, you don't have to provide for two cooling plants, and also you can actually look at the diversity and provide air conditioning where it's required, not a place where you are doing air conditioning in both the buildings and actually letting the energy being wasted. So these were some of the images. I will now quickly jump to an important aspect of design, which I wanted to highlight. Now, when we design a building like this, it's very important for architects to put this thing in front of a client to make them understand what all goes inside a building and what are stages they should expect. Generally, the market practice now, post 1990, has become that the day concept design is finalized, people expect that the construction can start in a week's time. And that's not the truth. Reason being that the more time you spend in designing and planning of a building, the more accurate you would be at the end result. So if I have designed something which would have X, Y, Z feature in it, and if I plan for it well in advance, I would be able to achieve that. And how can I achieve that? That would be mean that I have to break this whole complex project into various stages of planning. The first stage of planning is what I showed you was a concept design stage. This is where you actually set the goals for the project. And it would mean looking at the sustainability aspect, daylight aspect, air conditioning aspect, the lighting, getting client to agree for the cost. I'm sorry. I will.
We lost your feed.
Yeah. Can you see it now?
Yes.
Can you see my screen? Yeah.
Yes.
So this is what goes into a concept design stage, and these are the general deliverables in the concept design stages, which would include all of these, including lots of reports, the sustainability analysis, the traffic flow, the design basis reports for the structure, for the electrical, for the plumbing, and all of that, and a project budget, which is very important when it comes to a live project. Reason being, most of these features actually, by the time they have to be executed, are thrown out of the window because they have not been budgeted for. So if you budget them from day one, and if you make it integral part of the whole scheme, you would be able to execute it because the client knows, okay, I don't have to pay extra for it, and actually it's helping me. A simple example: if I would not budget for insulation, what would it end up being? uh, the insulation will not be implemented in the project because that cost has not been taken into consideration. What would that mean? That would mean that your air conditioning demand would increase. That would also mean your electrical demand would increase. What would that mean to the client? It would mean instead of buying a 100-ton chiller, the client would end up buying a 150-ton chiller. And we say, "Chalo, 50 ton hi to extra lag raha hai." But in the overall life cycle cost of that building, this whole thing will have an impact where you will the cost of the insulation, which could have been recovered in 3 or 4 years, will go for a toss, and the building will pay for this mistake throughout its life of about 60 years. So that's why it's very important to have these part of the concept design stage from the early on stages and include them. The second stage and the most important stage is the schematic design stage, which is when you actually get your consultant to vet your design, make sure that they are as per the requirements. You have your single line diagrams, you have your requirements for air conditioning, your locations for all the shafts and other things, so that you don't face the problems when you are going into actual execution. After that comes your statutory approval stage. Now, in all of these stages, you need a sign off from a client. If they don't take a sign off, it would actually mean that, oh, uh, you're just doing it for yourself, and if you don't make them part of it, they will not agree to it at a later stage. The- After that comes your statutory approval stage, which is when mostly you get your licensing done, which is the approvals from the local bodies. And in parallel to that, you would run a design development stage. This is more developed, this is more detailed stage than your schematic stage, because here you are actually putting the real dimension that would end up becoming tender drawings and help the person who's bidding for it understand the building well in advance. If you have not put those things in building in early stages, then the person who's bidding for it will miss lots of important details and end up not voting for it. Then comes last is your good for construction drawings. Now that includes all kinds of drawings, and I would always recommend to have GFC drawings in place before you actually break ground, because otherwise you will end up messing up with the project. I will quickly show one of the project timelines so that you get an idea of what it means when you are sharing it with the client. Now, this is something which we do with our clients even before we get on board, which would mean even before you are about to sign an agreement with the client, you should tell them in advance, expect so many days for the concept design, expect so many days for schematic design. Then comes your statutory approvals. Your design development will happen in parallel, which means when statutory approval drawings are going and getting approved between 29th August to 16th December. Meanwhile, you have a time to finish your design development and tender stages and have good for construction drawing the moment you are about to start the construction. This is how it looks in a bar graph. If you can see my screen, the concept design then leads to schematic. The statutory approval takes longer period. That's where you do design development, tender stages, and good for construction drawings. It's always important to finish it before the actual execution on site start. Uh, I will share some more important insights of this project, which we included during the tender stage, uh, which is some of the drawings. So, so now when I meant that your contractor needs to know all of these details in advance, this is what it would mean your tender drawing should look like. It would mean that you have already included insulation as a part of the building design. It should also show your building elevation of how, if there is a double facade, what would it mean, where will it get supported. Of course, you will not have a good for construction detail for it. Your structural consultant might have not even detailed what would be the size of this member. But at least having this in place will give the person who's bidding for the project understand, okay, so many things needs to be done, and this is how I need to plan for the project. Otherwise, he will either miss on the cost or miss on the time, which is what the client would not want to compromise on. It should also include details like terrace waterproofing, insulation, and all of these things. So these are some of the sample drawings which I'm showing you, becomes part of the tender stage. And there are about uh, 15 to 20 sections that we share with clients and the contractors before they bid for a project. And then thereafter, they go into the construction stage where they see the details of each and everything. So now have I crossed the time because there is another project
Yes,
I want
yes,
to.
you have. I think what we could do is the rest of this we can take up in the
Yeah,
one discussion with
right.
the 369 Ocker Studio. And we can move to the residential one and quickly cover because
Yeah,
the rest of the six practices have residential
right.
projects. Yeah.
I will quickly jump to the residential one. It's the short one. So this was a project in Defense Colony, Delhi, in an urban landscape which had few existing trees. The client loved the trees, and we too. We wanted to save them. So these were some interior pictures of this existing building. We decided to reclaim all the wood, whatever was possible, the teak which was used, and reuse them. So we labeled them before the demolition started and made them a part as an inventory list for the tender when it was about to come. The design was again based on the principles of passive architecture, solar passive architecture. So we made sure that you get good winter sun. Now, during the concept design stage, we made more than 40 or 50 options for these kind of plans so that the client doesn't change it at a later stage. We wanted to make sure that they don't end up saying, what if this study room goes on this side and the bedrooms goes on that side. So to avoid that, we did all the iterations during the concept stage itself. That's why you need more time during the concept stage than your later stages where client would end up changing. These were some features. The important features were the super insulated roof. We Because from the initial stages, we got clients to understand, even in concept design, that your wall thicknesses will be much higher, which will give you more comfort. They knew what would be the room sizes. This gave them the confidence to understand, okay, if we are losing on some square foot of area in a prime location like Delhi, we still get better comfort inside the building. And that's why it was important for us to make this part from the concept design stage itself, which would mean an external CACB block, insulated material, insulation material inside, and then an internal wall, which would make a complete thickness of about 450 mm. Efficient double glazing, cross ventilated spaces, indoor air quality, because Delhi has a huge problem of PM 2.5. We decided to go with an air conditioning system which would allow fresh air to come inside the building without compromising on the indoor quality. So there were various air conditioning systems which we utilized for the building. Low carbon material, locally sourced, and these are some of the pictures that are renders which we created. This is now under construction, getting built in CSP block with lots of stone, the local stone which is available. So the plain color things that you see brown are the stone, and the rest all is the CSP block. These are some more images, and this is how it would look. So it would not look like any other builder house that you see in Defense Colony or in Delhi, but something. Well, important thing we did was created a courtyard on the third floor of a building, which was a wow factor for the client. They wanted to feel that okay, it's a ground floor building only. So on their third and the fourth floor, we created a good connected large courtyard space. This is that courtyard space. Uh, these are some more renders. Now, even in this, we made sure that if we are going with CSCP, even before the project started, to go into the construction, we did lots of iterations in the color and other things, got them approved by the client, and then went to the tender stage. These are some details which I will share with the team when I will do one-to-one session. But all of this becomes part of the design. I'm not showing right now services, because services is a very complex process, which I will explain to the team. I'm right now showing architecture because it's important to understand as an architect, it's our job to include all of it. So it's important to include this drip irrigation in the early stages of design itself, and also to make sure that the thicknesses are already in place for everything that we are designing for. And these were the part of, again, tender drawings which we gave to the contractor. And this is where we spent a lot of time. Later on, it became much easier for us to execute it on site.